Last chapter, we turned a real person into a single, licensable row. But hold that row up to the light, and here's the thing you must never forget. It is a map of a patient, not the patient. The real person is the territory, messy, complete, alive. The dataset is a map drawn from it, flat, simplified, and full of holes where the territory kept going. Every dataset in health, without exception, is a partial map. And almost every serious mistake in this entire field is the same mistake, made over and over, quietly trusting the map as if it were the territory. So how do you read a map's limits before you trust it? 4 questions. Completeness. How much is simply missing? Every gap is a place the map goes blank. Longitudinality. How long can you actually follow one person? Because in the US, when someone changes insurer or health system, they often just vanish from your data mid-story. Provenance. Where did each fact come from, and can you trust that source? A billing code and a clinician's note are not the same kind of truth. And representativeness. Who is in this data, and just as important, who is systematically not? Ask these 4, and a dataset stops being a magic oracle and becomes what it is: a specific map with specific edges. And each source has its own signature blind spot baked in from where it was born, back in Chapter 2. Claims data is precise about billing and blind to clinical nuance. It can tell you a code was submitted, but not how sick the patient really was, or whether they got better. Single-system EHR data is rich, right up until the patient walks across the street to another hospital, and then it simply goes dark. Out-of-network care is invisible. Wearables see the day-to-day, but know nothing about diagnosis. The lesson underneath all of them: nothing is complete. Every map has an edge, and just past that edge, the territory keeps right on going. But the most dangerous blind spot isn't in the data. It's in who never made it into the data at all. A dataset only sees the people who touch the system, and who touch it in a way that gets recorded. So the insured, the urban, the people who regularly seek care are captured in high resolution. And the uninsured, the rural, the people who avoid the system or can't reach it, fade toward invisible. Now train a model on that map, and it quietly learns the map's blind spots as if they were facts about the world. It works beautifully for the people already well served, and it fails confidently for exactly the people who were already being failed. That is how a technically impressive product becomes actively harmful. Once you see it everywhere. Because every serious mistake in this field is really the same one. The data says adherence dropped, or did the patient just switch to a pharmacy you can't see? The data says the drug works, or does your dataset simply miss the sickest patients, the ones who died out of network, invisible to you? The data says the disease has this prevalence, or is that just the count of people who happen to get diagnosed and billed? Every one of these is the same error wearing a different costume. Reading a gap in the map as a fact about the territory. Absence of evidence, quietly promoted to evidence of absence. So here is the skill that separates the people who ship credible products from the people who ship confidently wrong ones. Before you build anything, you interrogate the dataset's fitness for your exact question. Run the 4 checks: completeness, longitudinality, provenance, representativeness. Trace the blind spots back to where the data was born, and always ask who is missing. Because you don't need a perfect map. There is no perfect map. You need to know precisely where your map's edges are, and then choose a question that lives safely inside them. Do that, and you're finally ready to build something real. Chapter 8, From Data to a Service.